In 5.2 and 5.3, we talked about two ideas, the incenter and the circumcenter. Both of these are points of concurrency. The question is, what are they points of concurrency for? One of them was the point of concurrency for an angle bisector. One of them was the point of concurrency for your perpendicular bisector. And that's the difference between them. Right? You need to make sure we have them because we're going to learn two more today. So on your Chapter 5 test, I'm going to give you the first four questions are going to be just straightforward definitions. They're going to be the four terms that we have here. We learned two of them so far. We'll learn the other two later today. The way the questions are going to be worded is going to say the intersection of the three angle bisectors is called a blank. The intersection of the three perpendicular bisectors is called a blank. And then today we'll do your medians and your altitudes. But you need to know that the incenter is the intersection of your three angle bisectors. Your circumcenter is the intersection of your three perpendicular bisectors. So make sure you know those terms. As I said, today we're going to get into two others. Your angle bisectors, your medians and your altitudes. So a median, what a median is, right? A median of a triangle is going to be a segment that goes from your vertex to the midpoint of your opposite side. Now, the easiest thing for me to do is draw one that looks kind of like this. It's going to go from your vertex to the midpoint of the opposite side. Notice it's different than a perpendicular bisector. The perpendicular bisector went to the midpoint too, but it was perpendicular to it. It didn't have to start at the vertex. That's the difference between a perpendicular bisector and a median. In your triangle, there are three of them. It goes from a vertex to the midpoint of the opposite side, so it splits it in half. From your vertex to the midpoint of the opposite side, so it splits it in half. From your vertex to the midpoint of the opposite side, so it splits that one in half. Right? So that's what a median is. Notice the three medians, they are concurrent. So that point of concurrency is going to have a name. It is going to be known as your centroid. It is the point of concurrency of your three medians. So here it is, point M. Now, point M, that centroid, is going to have a property though. It's not the same distance away from something or anything like that like the last two sections were. However, it is going to take that median and break it into two pieces. So if I look at one of my medians, let's look at median AZ. What this point M is going to do, it is going to break it up into two parts. Unfortunately, it does not just break it in half. However, it does break it into pieces that we can use. It breaks it into a 2/3 piece and a 1/3 piece. So for example, if my whole median was 24, 2/3 of 24 is 16. 1/3 of 24 is 8. So it breaks it up into a 2/3 piece and a 1/3 piece. And that's what your theorem is going to say. The medians of a triangle intersect at a point that is 2/3 the distance from each vertex to the midpoint of the opposite side. Now, one key thing here. You are going from the vertex to the midpoint. So the 2/3 piece always goes vertex to centroid, is the 2/3 piece. The 1/3 piece goes centroid to the other side. It'll be set up that way every time. The key is going to be, can you work through and find those missing parts? So take a look at example 1. It says in triangle FGH, M is your centroid. That means that we have three medians coming here. It says in GM is 6. So notice GM is part of this median. The whole median is GL. The 2/3 piece goes from your vertex to the centroid. So that would be GM. That would leave our 1/3 piece then to go from the centroid to the side. So the 1/3 piece here is ML. They're going to give us one of these pieces, and then you need to be able to find the other two. Here they give me GM to be 6. GM is the 2/3 piece. Your 1/3 piece is half as big as your 2/3 piece. So the ML would be 3. Which means if you add them together, you'll get your whole thing, which is 9. You could have also said that, okay, I have the 1/3 piece being 3. To get the whole thing then, you'd have to multiply by 3. And you get 9 anyway. You can do it either way, depending on the problem. Now, the other thing they can have you do is work with this centroid on an actual coordinate plane. When you do that, we need to find, so answering the question then, ML was 3, GL was 9. All right, as I was saying, they can also have you do this on a coordinate plane. So they give me the coordinates for triangle JKL there. It says find the coordinates of the centroid P of triangle JKL. So I plot my points. Now your medians are how you find your centroid. A median goes from a vertex to the midpoint of the opposite side. So the very first thing I have to do then is find my midpoints. Remember, a midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. So for JK, I add my x's. 1 plus 4 divided by 2. Add my y's. 2 plus 6 divided by 2. We get 2.5, comma 4. So there's my first midpoint. We could do KL. Add your x's. 4 plus 7 divided by 2. 6 plus 4 divided by 2. We get 5.5, comma 5. So there's my second midpoint. For our third midpoint, we do JL. We have 1 plus 7 over 2. We have 2 plus 4 over 2. So we get 4, comma 3. So there's my third midpoint. Now to do the math, there are 3 medians that are here. You are looking for a horizontal or a vertical median. Here we actually have both, so you can choose which one to do. I am going to do the one that goes vertically. And the reason I choose this one is it's all whole numbers. Remember, this one here had a fractional piece to it. That was 2.5, comma 4. So to avoid that 2.5 in dealing with decimals, I'm going to deal with whole numbers. So I'll call this point M. My median, KM, is 3 units long. Remember that your centroid is 2/3 the length. So your centroid is going to be located at 2/3 the length of your median. 2/3 of 3 is 2. So I count down from the vertex. We go down 2 then in this case. So if I go down 2, the coordinates I get here for my centroid P is going to be 4, comma 4. So there's our answer then. You will have one problem very similar to this on your test. right? So that's what you need to know about your medians. We also, though, talk about your altitudes. An altitude will go from a vertex, and it will be perpendicular to the other side. So what we're looking at then, if I draw, we'll just draw this triangle here. What an altitude does is it goes from a vertex, and it is perpendicular to the other side. Right? Essentially, it is the other part of our perpendicular bisector. Your median does the bisecting part. Now we're talking about the perpendicular portion. But for both of them, you have to start at your vertex. If you draw in your three perpendicular bisectors, your three altitudes. There was two. And there was three. The three altitudes do intersect at a point. That point will have a name, but it does not have a property. All you need to know is that the three altitudes are concurrent. The perpendicular segment in altitude is the perpendicular segment from a vertex to the opposite side. Now, it adds in this part or the line that contains the opposite side, because when you look at an obtuse triangle, I can draw this one in. That one was pretty easy to draw. I cannot draw the other two, though, because they are going to be outside the triangle. If I come to this top point, right, the opposite side, it's this horizontal line that's there. To be perpendicular to a horizontal line, I need to make a vertical. That's a bad vertical line. I need to make a vertical line. I can't intersect it. That's why it says, or the line that contains the opposite side. So I can extend this side out. There's my altitude. Likewise, I can extend this altitude out. So that now I have these two altitudes intersecting out here. I can extend this side out. So that when I draw my last altitude, notice they are all going to be concurrent again. No matter what type of triangle you have, your three altitudes will be concurrent. And that's all you need to know about them. There's no property to them. The lines containing the altitudes of a triangle are concurrent. That's it. There's no property to it. There's nothing unique about it. It's just that they happen to all meet at one place. So our last example here then, they also have a name. That point of concurrency is known as your orthocenter. The point at which the lines containing the three altitudes of a triangle intersect. All right, last example here. I want you to draw in and find that orthocenter of each triangle. The easy one is your acute triangle on the right. Go from your vertex, perpendicular to the other side. From your vertex, perpendicular to the other side. From your vertex, perpendicular to the other side. And a little hint for you, if you draw two of them, the third one has to go through that same intersection. So you can cheat a little bit. The key is, in an acute triangle, it will always be inside the triangle. Now let's go back to A. Let's do our right triangle. From your vertex, perpendicular to the other side. Now, when I go to the top one, when I go from my vertex here, if I want to be perpendicular to the other side was a horizontal line. So I'm drawing a vertical line. From this vertex, perpendicular to the other side was a vertical line, so we drew a horizontal line. If you notice, all three of them intersect at that point. They all intersect at your right angle. In a right triangle, your orthocenter will always be the right angle. Now, the hard one to draw is your obtuse triangle. You can do the one inside, vertex perpendicular to the other side. But to do the other ones, you need to extend your sides out. So I need to extend this side down. I'm going to need to extend this side over to draw my altitudes in. So from this vertex perpendicular to the other side, looks like that. Now remember, the altitude we already drew will need to be extended. So we already have that orthocenter. It's going to be right here. So now we can cheat if we wanted to. Got to go from that vertex, and we know we can go through that point. In an obtuse triangle, it is outside the triangle. Now, if you're following along in your note packet, in that next part, they give you an example that we're going to do a proof with. You are not going to be tested on any proofs. So do not worry about that as far as doing. If you want to try it on your own, you're welcome to. But I want you to get started on your homework here and have some time to do it. So there's your homework to go with section 5.4. If you have any questions, please make sure you let me know.